लास्ट वाला लेक्चर तो इंट्रोडक्टरी ही था. लेट मी स्टार्ट फॉर्मली टुडे विद the state space analysis. Of LTI systems. Of these are सारे पूरा हो गए. So as I told you last time, mathematical modeling. What do you mean by mathematical modeling? क्या कहा था मैंने?
This is an analysis.
हाँ.
First, we should know if we have any system. First, we should know the physics of that system.
Okay.
Then we will go for mathematical modeling and physical interpretation.
Mathematical modeling क्या होता है?
Mathematical modeling is the representation of any circuit in terms of mathematical
Equations. Not circuit necessarily. Any physical system.
Yes.
Any physical system in the form of equations. So in this semester, we are basically talking about mathematical modeling of LTI systems. LTI systems means linear time invariant systems, है ना? So mathematical modeling of LTI systems it can be done in two ways. One is transfer function modeling, है ना? And second is state space modeling. फोन आपको देना पड़ेगा. Transfer function modeling and state space modeling. Transfer function modeling you already done in fourth semester. This is a frequency domain modeling. Why do we call it frequency domain modeling?
Because sir, we take into consideration the frequency of the system.
Frequency variable, जो S variable है ना. So that's why it's transfer function modeling. And this is basically input-output modeling. दिख रहा है?
Yes, sir.
Input-output modeling. है? Input-output modeling means you model a system as the ratio of the Laplace transform of the output variable to the input variable. है ना? State space modeling is another way of looking at the same system. एक ही उसी सिस्टम को एक दूसरे तरीके से देखना. That's what is state space modeling. Are you getting me? And as I was discussing last time, ट्रांसफर फंक्शन मॉडलिंग की बेसिस पे जो कंट्रोल थ्योरी डेवलप हुई है दैट इज नोन एज क्लासिकल कंट्रोल. व्हाट डू वी कॉल इट? क्लासिकल कंट्रोल. और स्टेट स्पेस मॉडलिंग की बेसिस पे जो कंट्रोल थ्योरी डेवलप हुई है दैट इज नोन एज मॉडर्न कंट्रोल. ओके. एंड आई डिस्कस्ड दिस थिंग आल्सो लास्ट टाइम दैट saying that it's modern control and this is classical control should not lead to any confusion. If it is modern doesn't mean that it's more important. Are you getting me? Both have their own what I call importance in control theory. Transfer function modeling is as important as state space modeling. Now the reason why we call it state space modeling is, why do we call state space modeling as modern control? That the reason is because this is based on matrix theory, and matrices can be very easily handled with the help of computers. So since computers का इसमें अमल दखल आ जाता है, so that's why we call it modern. And this is based mainly on analytical techniques, mathematics, pure mathematics, Laplace transform, differential equation, directly we are dealing. So that's why this is known as classical control. Are you getting me? So transfer function modeling has been discussed in detail in your fourth semester, and as I was discussing with him last time, not to my satisfaction, but anyway we couldn't do anything about that. So in this semester our main focus will be state space modeling. So given a system, LTI system, the first aim will be to develop its state space model. So before developing the state space model, we must make ourselves conversant with the nomenclature of the things. What do you mean by state? What do you mean by state space? What does the model look like? वो सारी चीजें पता होनी चाहिए पहले. After that, we'll go into the details of the things. So purpose, main aim ये है कि अगर आपको कोई LTI system दिया गया है किसी भी एरिया का, किसी भी फील्ड से लेके, चाहे सर्किट से, मैकेनिकल सिस्टम है, केमिकल सिस्टम है, इवन बिजनेस मॉडल है. So if you have been given an LTI system and you are asked to obtain its state space model, you should know the procedure for that. You should be able to give me the state space model for the system. Are you getting me? So last time towards the end of the lecture, जो कि finally upload हुआ नहीं. So first of all, given a differential equation, what are the governing equations of linear time invariant systems? Differential. कौन सी differential equations? Ordinary differential equations. Linear or non-linear? Linear ordinary differential equations, है ना? Governing equations जो होती हैं LTI systems की, it's not working. इसको pause करो एक. Governing equations of LTI systems are, what did we say? Linear ordinary differential equations. In short, we write that as ODEs, है ना? Linear ordinary differential equations with constant coefficients. Linear ordinary differential equations with constant coefficients. Like जैसे ऐसी equation, मैंने last time भी ये equation लिखा था, md square x by dt square plus b dx by dt plus kx equal to f. An equation of this type. It is an ordinary differential equation. Why is this an ordinary differential equation? Why do we call it an ordinary differential equation? Because there is only one independent variable, d dt, है ना? What is the other category of differential equations? Partial. There are more than one differential operators in that. It is an ordinary differential equation. It is a linear ordinary differential equation. Why? How can you say by looking at the differential equation whether it's linear or non-linear?
Because its degree is 1.
No, its degree is not 1, its degree is 2.
Order is 1.
Order is 1.
नहीं कैसे?
Sir, order is 1.
नहीं. The order of this differential equation is 2. It's a second order differential equation. Second order differential equation है लेकिन फिर भी linear है क्योंकि ये जो operator है d square x by dt square, it's a linear operator. It's a, had it been like this, अगर ये ऐसे होता, then it's non-linear. Then it's non-linear. Are you getting me? This is linear. This is a linear ordinary differential equation with constant coefficients. Coefficients कौन हुए? ये वाले m, b, k. They are all constants. F is the input, x is the output. Are you getting me? F is the input, x is the output. F is the force, it's the input. ये basically एक spring mass damper system का equation है. Spring mass damper. गाड़ी का जो suspension system होता है, that is governed by this equation. This F is the force. This is the input. Okay? X is the displacement. Which is the output. How do I obtain the transfer function of the system?
So we'll apply Laplace transform.
On both sides, assuming
So initial conditions.
0. Very good. Assuming 0 initial conditions, and you will get the transfer function of the system. क्या मिलेगा transfer function of the system का? If we follow the proper procedure, we'll get xs upon fs, है ना? That is the ratio of the Laplace transform of the output variable to the Laplace transform of the input variable. This will get as 1 upon ms square plus bs plus k, है ना? It is a frequency domain modeling, as I told you. The variable that's used here is s, Laplace transform variable, है ना? So this is the transfer function of the system. ठीक है? So this transfer function is valid only for LTI systems. You cannot obtain transfer function for non-linear systems. Are you getting me? Transfer function is basically because Laplace transform can be applied only for linear systems, linear ordinary differential equation. And plus you assume initial conditions to be 0. And plus one more thing, transfer function जो है, it is more applicable to single input, single output systems. No doubt you can obtain transfer function for multi-input, multi-output systems also, but there it becomes less mathematically convenient form में नहीं आता है. ज़्यादा applicable है ये to single input, single output systems. These things you must keep at the back of your mind. It's frequency domain modeling. Then what next I told you that applicable to LTI systems, and it's more what you call applicable to conveniently it can be applied to single input single output systems. ये चीजें आप ध्यान में रखोगे. Now for the same system that is ms square plus b क्या था md square x by dt square plus b dx upon dt plus kx equal to f. If I am asked to obtain a state space model, अभी हमें पता ही नहीं है state space क्या होता है. Just I want you to have a look at what the state space model looks like. अगर मुझे इसका स्टेट स्पेस मॉडल ऑब्टेन करने के लिए कहा जाए तो उसके लिए प्रोसीजर क्या है. ये बेसिकली एक फिजिकल सिस्टम था, स्प्रिंग मास डैम्पर सिस्टम. उसका पहले हमने मैथमेटिकल मॉडल लिखा इन द फॉर्म ऑफ एन इक्वेशन. Now for the same equation I am being asked to obtain its state space model. What is the procedure? The procedure is very simple. So we will define something like x is the variable here, we put it equal to x1. Okay, so there should be no issue with this. We are putting x equal to x1 and dx by dt, which can also be conveniently sometimes represented as x dot, that I put equal to x2. Okay, I put x equal to x1 and x dot equal to x2, which actually implies, because x is equal to x1, that actually implies x1 dot equal to x2. है ना? This becomes my equation 1. Okay, let me call this as equation A. If I substitute in equation A, what do I get? This is m here, I put it m. Okay, so d square x by dt square is actually d by dt of dx by dt, isn't it? Dx by dt is x2, d by dt of x2, what's that? That is x2 dot, isn't it? Plus b dx by dt is x2, है ना? Plus k, x is x1 equal to f. सही है? Then what do? I put x2 dot on one side and take the other things on the other side. So I will get minus k upon mx1. सही है? Minus b upon mx2 plus 1 upon mf. सही है? I call this as equation number 2. The order of the original or the degree of the original differential equation was 2. What is the order of this equation?
1.
What is the order of this equation? 1. So basically what I have done is that a second order differential equation has been decoupled into two first order differential equations. Are you getting me? This is what is done in state space modeling. So in general, if you have an nth order differential equation governing a system, you decouple that into n first order differential equations. Are you getting me? So in effect what I have done, a second order differential equation has been decoupled into two first order differential equations. Are you getting me? Now, if I write these two equations, 1 and 2, in the form of matrices, in matrix format, expressing 1 and 2 in matrix form, what do I get? ये वाली equation. So I write like this: x1 dot x2 dot is equal to and x1 x2. Now x1 dot is equal to x2. So this is 0 and 1. x2 dot is minus k upon m x1, so this is minus k upon m, this is minus b upon m, है ना, plus there is 1 upon mf, this is 0, this is 1 upon m, and this is f. Are you getting me? सही है ना? This is how a state space model looks like. State space model का एक हिस्सा है. State space model के actually दो हिस्से होते हैं. One is what is known as the state equation. This is actually the state equation. And second equation is what is known as the output equation. Okay? जैसे अभी मैंने previously आपको कहा जब हमने इसका transfer function obtain किया, I told you f is the input and x is the output. So here x is the output, f is the input, f यहाँ पे आ गया, x is the output, isn't it? So I will, once I have defined this thing, I'll also define, I have put x equal to x1 and dx by dt equal to x2. So output y, I'll name output as y. That's equal to x, which is in turn equal to x1. So y is basically equal to x1. Are you getting me? So what does the output equation then become? Matrix form है. Output equation is y is equal to 1, 0, x1 and x2. सही है? Y is equal to x1. ये complete state space model बना. State space model के दो हिस्से होते हैं, state equation, output equation. तो ये वाला जो मैंने ये जो मॉडल बना यहाँ पे, this is known as the state space model. अभी भी हमें नहीं पता कि इसको state space model क्यों कहते हैं. ये मैंने आपको just mechanically बताया कि अगर equation दी हुई है उससे हम state space model कैसे obtain करते हैं. Are you getting me? लेकिन as a control engineer that's not sufficient. We must be able to correlate it to the physics. Are you getting me? So जैसे मैंने अभी आपको कहा state space model के दो हिस्से होते हैं. ये वाला equation जो बना, ये वाला, इसको state equation कहते हैं. क्या कहते हैं? और ये वाली equation जो बनी इसको output equation कहते हैं. Getting me? This is the input, f is the input, and y is the output, isn't it? So a state space model has two parts, a state equation and an output equation, and this is what they look like. ये second order differential equation थी, इसलिए corresponding matrices और vectors जो यहाँ पे बने, उनके appropriately वैसे ही order बना. जैसे ये जो matrix है, इसका it's a 2x2 matrix. But had the original differential equation been a third order equation, this would have come out to be 3x3. Are you getting me? Similarly, if you see this vector, this is known as basically as the input vector. I'll explain it properly. इसका जो size है, it's 2x1. Are you getting me?
Yes,
Wherein 2 actually represents the order of the original equation, and जो 1 इसमें आया, एक column जो इसमें आया, that is corresponding to the number of inputs. इसमें एक input है ना, तब ये 2x1 आया. अगर इसमें दो inputs होते हैं, so it would have one more column. This vector would have one more column, or this would have become a matrix that time. Similarly, this is the output. Output इसमें एक है, single output. तभी ये जो number of rows जो इस matrix में होते हैं, they correspond to the number of outputs. Had there been more outputs, it would have one more row. वो मैं आपको डिटेल में समझाऊंगा. मेरी बात समझ रहे हो? तो ये एक सिंपल मैंने आपको तरीका बताया किसी भी गिवन डिफरेंशियल इक्वेशन को कैसे स्टेट स्पेस मॉडल के फॉर्म में एक्सप्रेस करते हैं. इसको स्टेट स्पेस में स्टेट्स क्या होती हैं, इसको स्टेट स्पेस क्यों कहते हैं, वो मैं आपको एक्सप्लेन करूंगा. डू यू गेट मी? इज दैट क्लियर? So continuing with the same thing, I'll come to this equation later on once again. अगर आप देखो इस इक्वेशन का जो ओवरऑल ये बना स्ट्रक्चर, वो कुछ ऐसा बना, x डॉट इक्वल टू ax प्लस bu एंड y इज इक्वल टू cx, है ना. वेयर दिस x इस पर्टिकुलर केस में, वेयर दिस x डॉट इज x1 डॉट एंड प्रीवियस वाले केस में x जो है दैट इज x1 एंड x2, है ना। u जो है दैट इज 1/f, नहीं सॉरी f, है ना। y जो है वो आउटपुट है, y इज द आउटपुट, है ना, u इज द इनपुट, y is the output. This x is again x1 cross x2. a का डायमेंशन क्या है उसमें 2 क्रॉस 2, b का डायमेंशन क्या है 2 क्रॉस 1, c का डायमेंशन क्या है 1 क्रॉस 2, है ना। x का डायमेंशन क्या है 2 क्रॉस 1, देखो आप ये कंपैटिबल होने चाहिए ना, 1 क्रॉस 2 2 क्रॉस 1, दैट मेक्स इट 1 क्रॉस 1 विच इज दिस आउटपुट, एक ही आउटपुट है ना, है ना। सिमिलरली हियर एक इनपुट है दैट्स 1 क्रॉस 1, x is 2 cross 1. So these 2 cross 2 multiplied by 2 cross 1, that makes it 2 cross 1. 2 cross 1 multiplied by 1 cross 1, that makes it 2 cross 1. Once you have to add two matrices, they must have the same dimensions. 2 cross 1 plus 2 cross 1, that makes this as 2 cross 1. Isn't it? In general, had your equation been an nth order differential equation, what would have been the side dimension of x? अगर ये nth order differential equation होती, it would have been n cross 1, है ना। ये n cross 1 होता उस केस में, सॉरी दिस नॉट दिस, x होता है n cross 1, है ना, a आता है n cross n, b would have been n cross 1, u तो है ही 1 cross 1, है ना, c would have been 1 cross n, x would have been n cross 1, जहां जहां पे 2 था वहां पे n आएगा, आर यू गेटिंग मी। तो ये जनरल में आपका स्ट्रक्चर बन जाता है स्टेट इक्वेशन का ऐसा, आर यू गेटिंग मी। डायमेंशंस आर वेरी इंपॉर्टेंट बिकॉज वंस यू आर एक्सप्रेसिंग समथिंग इन द फॉर्म ऑफ मैट्रिसेस, they should be compatible, everything should be compatible, isn't it? So I'll come to this once again, I'll give you the names of these matrices, what is A known as, what's B known as, what's C known as, और इसमें एक मैट्रिक्स मिसिंग भी है, y की इक्वेशन जो फुल इक्वेशन एक्चुअली आती है दैट इज y इज इक्वल टू cx प्लस du। प्रीवियस में जो हमने सिस्टम लिया इक्वेशंस का, उसमें y की इक्वेशन में u नहीं आ रहा था, लेकिन इन जनरल में आता है, तो वो एक और मैट्रिक्स आता है उसमें, विल गो समटाइम्स आफ्टर दिस, विल अगेन कम टू दिस इक्वेशन, आर यू गेटिंग मी, and I will tell you what is state and what's the other thing in this. Now let me take you somewhere else. For example, you have a system like this. I'm a physical system पे आया, ठीक है, ये आउटपुट में यहाँ पे ले रहा हूँ, this is the output. This is an RLC circuit excited by a voltage source, and voltage across the capacitor is taken as the output. This is an LTI system. It's a linear system. Why is it a linear system? Because all the these parameters used here are linear. R is linear, L is linear, C is linear, है ना? And we are considering it to be time invariant. That means R, L and C are assumed to be constant with respect to time. They don't change with time. That's what is a time invariant system. Now for this system, you have obtained the transfer function. How do you obtain the transfer function of the system? First you write down its equation. तो मैं यहाँ पे उसके लिए मैं पहले एक intermediate variable define करता हूँ I, है ना? Then I apply KVL to this loop and I write down the equation. So what do I get the equation as? VIT is equal to RIT plus L di by dt plus 1 by C integral of IT dt, है ना? I actually this is IT, है ना? Are you getting me? Now because I have to finally obtain the transfer function of the system, I apply Laplace to this, assuming the initial conditions to be 0. Apply Laplace transform on both sides, है ना? Assuming initial conditions equal to 0. So what do I get? I get VIS is equal to RIS plus LSIS plus 1 upon CSIS. क्योंकि इनिशियल कंडीशंस मैंने जीरो ली, वो बाकी वाली टर्म्स इसमें आई नहीं, जो कि इनिशियल कंडीशंस पे डिपेंडेंट होती हैं। तो एक चीज़ आप नोट करोगे कि जो टाइम इक्वेशन है उसमें वेरिएबल्स को लोअर केस में लिखा जाता है, जब लैपलेस ट्रांसफॉर्म लेते हैं वी राइट डाउन द वेरिएबल्स इन अपर केस. दिस कन्वेंशन शुड बी फॉलोड ऑलवेज. ओके, so what do I get? VIS is equal to, we get it this as, I get this as LCS square plus RCS plus 1 है ना upon CS into I. सही है, ठीक है ना. नाउ ये बन गई इक्वेशन 1. जब मुझे ट्रांसफर फंक्शन सिस्टम की ऑब्टेन करनी है, आई मस्ट ऑब्टेन द रेशियो ऑफ द लैपलेस ट्रांसफॉर्म ऑफ द आउटपुट वेरिएबल टू द लैपलेस ट्रांसफॉर्म ऑफ द, नाउ आई राइट ऑन द आउटपुट इक्वेशन आल्सो. ओके, what is V naught t equal to 1 by c integral of it dt, है ना. I apply Laplace to this also. Apply Laplace transform. Assuming zero initial condition. ऐसे सिस्टम को क्या कहते हैं जिसमें इनिशियल कंडीशन जीरो? Such a system is known as a relaxed system. A system for which initial conditions are zero is known as a relaxed system. Getting me? So what do I get? I get V naught S is equal to 1 upon CS IS. सही है, ये बन गई इक्वेशन 2. I want the transfer function, so I divide 2 by 1. What do I get? I get V naught S upon VIS is equal to 1 upon LCS square plus RCS plus 1. So this is the ratio of the Laplace transform of the output variable to the Laplace transform of the input variable. So this is the transfer function, and we in general represent it as GS. So GS is this. This is the transfer function of the system, and it can always be expressed in block form like this. This is VIS, this is V naught S, this is 1 upon LCS square plus RCS plus 1. This is the transfer function of the system, of the given system. सही है. मेरे पास एक फिजिकल सिस्टम था, उसको मैंने मैथमेटिकल फॉर्म में कन्वर्ट कर दिया. तो फर्दर एनालिसिस जो इस सिस्टम का होगा दैट विल फॉलो फ्रॉम दिस. जैसे टाइम रिस्पॉन्स एनालिसिस टेक्निक आपने पढ़ा आपके 4th सेमेस्टर में, जिसमें हम स्टैंडर्ड टेस्ट इनपुट से अप्लाई करते हैं सिस्टम्स को, लाइक स्टेप इनपुट, रैंप इनपुट, पैराबोलिक इनपुट, फिर उसका आउटपुट देखते हैं, और उस आउटपुट की बेसिस पे हम सिस्टम को करेक्टराइज करने की कोशिश करते हैं कि सिस्टम कैसा है. जैसे आपने सेकंड ऑर्डर सिस्टम्स पढ़े, अंडर डैम्प्ड, ओवर डैम्प्ड, क्रिटिकली डैम्प्ड. सो ऑल दिस फॉलोज फ्रॉम द मैथमेटिक्स. And once we have solved the mathematical equation, then as control engineers, it's your duty to actually interpret those mathematical results physically. क्योंकि मेरे को actually physical system analyze करना है. Mathematics is only a tool in analyzing this system. I must be able to give a physical interpretation to things. Are you getting me?
Yes, sir.
So I have converted the system from physical domain to mathematical domain and I obtained the transfer function of the system. This procedure you know. Now for the same system, I should be able to obtain its state variable model also, or state space model also. So what is the procedure for that? Are you getting me? मैं इसी सिस्टम का आप स्टेट स्पेस मॉडल ऑब्टेन करूंगा. इससे पहले मैंने आपको दिखाया कि अगर आपको डिफरेंशियल इक्वेशन सिस्टम की वहीं से बताई गई है, उसको आप कैसे कन्वर्ट कर सकते हो स्टेट स्पेस मॉडल में. Now for this system, which is actually a physical system, I will try to obtain its state space model. Are you getting me? So in the once I obtain its state space model, I'll also tell you some new terms will come up, like state and state space. What do we mean by that? Is that clear? Abhi tak clear?
Yes, sir.
Same system. I'm being asked to obtain its state space model. So what's the procedure? So the problem is to obtain the state space model of RLC series circuit, है ना? What is the procedure? Simple, very simple. You have to identify the dynamic variables in the system. Identify the dynamic variable. So what are the dynamic variables in the system? You have an inductor here, you have a capacitor here. Dynamics of the system is due to the energy storage elements. Had there been only resistance in this circuit, you would not call it as dynamic system, you would call it a static system. डायनेमिक सिस्टम वो सिस्टम है जिसमें कि एनर्जी स्टोरेज एलिमेंट्स हो, और एनर्जी स्टोरेज एलिमेंट्स के साथ जो वेरिएबल्स एसोसिएटेड होते हैं, दोज आर द डायनेमिक वेरिएबल्स. लाइक इंडक्टर, you always say that the current through the inductor cannot change instantaneously. So current through the inductor is the dynamic variable. And you also say voltage across the capacitor cannot change instantaneously. So voltage across the capacitor is the dynamic variable. तो किसी भी physical system को अगर आपको state space variable obtain करना है, you will have to identify first of all the dynamic variables. And dynamic variables को identify करने का easy तरीका है कि जो energy storage element system में present हैं, उसके साथ जो dynamic variables associated हैं, उनको choose करो as the dynamic variables. Are you getting me? So this is RLC circuit. You could even have a mechanical system, spring mass damper system. उसमें different types के dynamic variables होंगे. तो किसी भी system का model obtain करने के लिए ज़रूरी है कि आपको उस system की physics पता हो. मैंने circuit की example ही क्यों ली? Because we are conversant with circuits. Are you getting me? Had it been a chemical system, we don't know its physics. So that's why it will be difficult for us to obtain its state space model. Are you getting me? Otherwise, any dynamical system which is LTI system can be represented in the form of a state space model. So what is the first step in this? You identify the dynamic variables. So dynamic variables, an easy way of choosing the dynamic variables is choosing the dynamic variables is to choose the variables associated with energy storage elements. Is to choose the variables associated with energy storage elements as the dynamic variables. As the dynamic variables. Like in this case, the current through the inductor. That means this current, which is actually IT. In series है ना, IT. This will be chosen as one dynamic variable. Voltage across the capacitor. If I call it VCT, this will be chosen as another dynamic variable. तो जितने एनर्जी स्टोरेज इंडिपेंडेंट एनर्जी स्टोरेज एलिमेंट्स होंगे सिस्टम में, उतने डायनेमिक वेरिएबल्स आपको चूज करने हैं. मान लो इंडिपेंडेंट, व्हाट डू आई मीन बाय इंडिपेंडेंट? हैड इट बीन टू इंडक्टर्स एंड अ कैपेसिटर. Two inductors means a single inductor because it can always be combined. So that doesn't mean it has three energy storage elements. Are you getting me? तो किसी भी सिस्टम में जितने इंडिपेंडेंट एनर्जी स्टोरेज एलिमेंट्स होंगे, उतने आपको डायनेमिक वेरिएबल्स पहले आइडेंटिफाई करने हैं. Are you getting me?
So then, sir, it means that we have only two dynamic systems, electrical systems, two dynamic variables.
Yes, dynamic variable associated with L and dynamic variable associated with C. Are you getting me? अब उनकी डिफरेंट कॉम्बिनेशंस हो सकती हैं सर्किट में. जैसे मान लो मेरे पास एक सर्किट ऐसा होता है जिसमें कि एक C यहाँ से भी है, वो इसके साथ कंबाइन नहीं ना हो सकता. That will be another energy storage element. Are you getting me? So you can have, but the type of dynamic variables will only be two. Electrical circuits में. Are you getting me? When you talk about motors and machines, then comes the mechanical part भी आता है ना, उसमें कुछ और dynamic variables भी आ जाते हैं फिर. लेकिन अगर आप pure electrical circuit लो, आपके पास बस दो types of dynamic variables होंगे. Current through the inductor and voltage across the capacitor. Are you getting me? Like in this case, So current through the inductor that is IT, and voltage across the capacitor that is VCT are identified as the dynamic variables, or what we call as states. इन्हीं डायनामिक वेरिएबल्स को क्या कहते हैं? States. Now this thing has come. Are identified as dynamic variables or states of the given system, है ना? इन्हीं डायनामिक वेरिएबल्स को स्टेट्स कहते हैं. क्यों कहते हैं स्टेट्स, अभी बाद में बताऊंगा. फिलहाल हमने ये समझा कि जो डायनामिक वेरिएबल्स होते हैं सिस्टम में उन्हीं को स्टेट्स कहते हैं. क्या कहते हैं? स्टेट्स. तो यही वाले जो डायनामिक वेरिएबल्स मैंने डिफाइन किए IT और VCT, इनको मैं रीनेम करता हूं. I put IT is equal to x1 and VCT is equal to x2. ये दो डायनामिक वेरिएबल्स जो मेरे सिस्टम में हैं, जिनको मैं अब मैं स्टेट्स कहता हूं. So I rename them. I call this as x1 and this is x2. So how many states does the system have? Two states. So what are states actually?
States are
Dynamic variables associated with the system. So I am defining two variables here. Are you getting me? Now using my physics of the system, I write down equations. KVL laga ke. I write down equations for the system. And the equations I'll express in terms of x1 and x2. This IT is x1, है ना? This VCT is x2. Isn't it? And what is the output? Voltage across the capacitor. That is VCT. Output YT. से मैं represent करता हूँ ना उसको. That is actually voltage across the capacitor. That is VCT. वो वहीं से बताया है. Voltage आपको designated होगा, output designated होगा वहीं से. क्या output कौन सा है? Output is VCT. So and what's that equal to? That is x2. है ना? Now I apply KVL and I write down its equations. All of the equations look like I apply KVL to this. So what will I get equation as? I get VIT is equal to RIT plus LDIT by DT, है ना? Plus VCT, है ना? Or I can write VIT is equal to R. What is IT? X1 plus L DIT by DT.
x2.
No. X1 dot. What is VCT? X2. सही है? Or I can write down x1 dot I put on one side. The other things I take on other side. So that will be minus R by L x1. नहीं plus नहीं minus 1 by L x2 plus 1 by L VIT. सही है? VIT इनपुट है. इसको स्टैंडर्ड स्टेट स्पेस के फॉर्मेट में डालने के लिए इनपुट को हमेशा यूज से रिप्रेजेंट किया जाता है. किसे किया जाता है? सो सिंस आई हैव रीडिजिग्नेटेड द वेरिएबल्स लाइक दिस, इनपुट जो है, इनपुट क्या है? VIT. आई पुट दिस इक्वल टू UT or U simply. Just renaming the variables. I have not done anything. So what will I get here? X1 dot equal to minus R by L x1 minus 1 by L x2 plus 1 by L into U. सही है? This I call as equation number 1. ठीक है ना? Okay.
Equation A रखते हैं, हमने equation first रखी है.
1 या नहीं? A कहाँ से आ गया? वो तो पुरानी, वो तो खत्म हो गया. ठीक है? Okay. Now this is one equation. Now what is the current through the capacitor equal to? करंट थ्रू द कैपेसिटर, वो भी IT है, उसकी फॉर्मूला क्या है, C dVc by dt, है ना, which I can write as, what is IT? X1 C dVc by dt, x2 dot. I put x2 dot on one side, for x2 dot equal to 1 by C x1. This becomes my equation number 2. And output equation already वो है ना, ये वाली दो इक्वेशंस जो है मेरी, ये स्टेट इक्वेशंस हैं, है ना, और वो आउटपुट इक्वेशन है. ये दो स्टेट इक्वेशंस जो है इनको मैं मैट्रिक्स फॉर्म में लिखूंगा. आर यू गेटिंग मी? सो एक्सप्रेसिंग 1 and 2 in matrix form. What do I get? I get x1 dot x2 dot is equal to x1 dot की equation ये है ना, so I'll write like this. This is like this. I put here x1 and x2. So yeah. So you've got minus r upon L minus 1 upon L, and x2 dot की equation में you have got 1 upon C and 0. So yeah, plus इस equation में 1 by L u भी है ना, so this is 1 by L, this is 0 and this is 0. Yes, इनायत, ठीक है. So this becomes your state equation. ये अभी आधा हिस्सा है आपके मॉडल का, अभी मैंने आउटपुट इक्वेशन भी लिखनी है. ये बन गई स्टेट इक्वेशन. आउटपुट इक्वेशन क्या होगी? आउटपुट इक्वेशन विल बी y equal to yt equal to y, for the ease of t साथ साथ लिखने की जरूरत नहीं है, I can simply put as y. So y is equal to, that is x2 है ना, 0 1 x1 and x2. Isn't it the same format that we had obtained for the earlier system? Isn't it?
Yes, sir.
This equation, how many states my system has? 2 states. That's why you get this structure of the system. This is 2 cross 2, this is 2 cross 1 and so on. How many inputs do you have? 1. So that's why you get only one column here. How many outputs you have? You have got one output. So that's why you get one row here. अगर दो outputs आपके पास होते, मान लो आप current through the inductor को भी output लेते, so you'd have got another output or another input, whatever. So this is what is the state space model for the system. And what are these two? x1 और x2 क्या है? What do we call them? States. So these are the states of the system. What is x1 and x2? States of the system. And when you talk about states of the system, immediately it should come in your mind that these are the dynamic variables associated with the system. Are you getting me? These are the dynamic variables associated with the system. And so these are the states of the system. x1 and x2 are the states of the system. And this matrix, you can see these matrices, this x, ये वाली matrix, ये वाली matrix and ये वाली matrix. These actually comprise of the system parameters. R, L, C, है ना, इन्हीं चीज़ों का बना हुआ ये system constants जो है. Okay. Now, so this is known as the state space model for this system. ये वाला जो model बना पूरा, ये इसका state space या state variable model फिलहाल हम कहेंगे इसको. State variable model भी कह सकते हैं. That's again same as state space model. So given a physical system, this is how you obtain the state variable model for the system. Are you getting me? This is the procedure. So the first and foremost thing is that you should be able to identify the dynamic variables in the system, which are known as the state variables of the system. And once you identify the dynamic variables of the system, then you write down the equations. Are you getting? Since there are two dynamic variables here, you expect two differential equations, first order differential equations. That you get two first order differential equations, x1 dot और x2 dot. तो जितने dynamic variables होंगे systems के, उतनी differential equations आपके पास आ जानी चाहिए. In general, if you have an nth order differential equation, you should get n state variables for the system. Are you getting me? Once you choose the state variables, then you write down the equations and then express it in matrix form. You will end up with the state space model of the system. Are you getting me? Now, the one point that I want to make here is that, now this is my choice. I called it x1 and this as x2. What if I had called this at x2 and this at x1? I would have got another state variable model for the system, which is actually equivalent to this. The point that I'm trying to make is that you can have many state variable models for a system. ट्रांसफर फंक्शन सिस्टम की यूनिक होती है. किसी भी सिस्टम की ट्रांसफर फंक्शन यूनिक होती है अगर आपने इनपुट आउटपुट पेयर को डिफाइन किया हुआ है. If you have defined an input output pair, the transfer function of a system is unique. But you can have infinite state variable models for a system, for a given dynamical system, depending upon how you choose the state variables. State variables को कैसे choose कर रहे हो, ये point थोड़ा सा बाद में और clear हो जाएगा. It will become clearer later on once you talk about how we say that. फिलहाल आप ये point note करके रखोगे कि the transfer function model of a system is unique with the given input output pair for a given input output pair. Whereas you can have many state variable models for a system. Transfer function model of a system is unique for a given input output pair. Whereas you can have infinite state variable models for a system. You can have infinite state variable models for a system depending upon how we choose the state variables. कैसे हम choose करते हैं state variables को. Got it? Now I will come to the definitions. जैसे मान लो ये डिफरेंशियल इक्वेशन है एक, ये मैट्रिक्स डिफरेंशियल इक्वेशन है ना? मैट्रिसेस के फॉर्म में है ना? अगर मैं आपको कहूँ कि डिफरेंशियल इक्वेशन सॉल्व करो, किसी भी डिफरेंशियल इक्वेशन को, इन जनरल इफ आई गिव सम डिफरेंशियल इक्वेशन टू सॉल्व, व्हाट शुड बी गिवन टू यू? एंड द इनपुट. इनपुट पता होना चाहिए ना? इनपुट पता होना चाहिए, इनिशियल कंडीशंस पता होनी चाहिए, देन यू कैन सॉल्व द डिफरेंशियल इक्वेशन. सेम होल्ड्स ट्रू फॉर दिस थिंग आल्सो. इफ आई आस्क यू टू सॉल्व दिस डिफरेंशियल इक्वेशन, यू विल टेल मी कि बताओ सर इनपुट क्या है और बताओ इनिशियल कंडीशंस क्या है. Once I give you those two things, you should be able to solve this differential equation. And what will be the solution of this differential equation? Initial conditions किस चीज की? हाँ, means states की. Dynamic variables के corresponding आपको initial conditions पता होनी चाहिए, isn't it? That means x1 और x2 का value आपको पता होना चाहिए at time t equal to 0 और in general at time t equal to t0 किसी भी initial time पे. और आपको इनपुट पता होना चाहिए, इनपुट पता होना चाहिए फॉर ऑल टाइम्स t greater than or equal to t0, isn't it? So if I give you these two things, you should be able to solve this differential equation. And what will be the solution of this differential equation? That will be x1 and x2 for all times, isn't it? और वो x1 और x2 का जब वैल्यू आपको मिल जाएगा for all times, you substitute it here and you'll get y. Are you getting me? So this should give an idea about how do we define states. The states of a dynamic system, or the state of a dynamic system, is defined by a set of variables which are the dynamic variables of the system, such that if you know these variables at some initial time and you also know the input, then the complete system is known to you. Then the complete, so basically the state of the dynamic system is governed by a set of variables x1, x2 up to xn, such that if you have the knowledge of these variables at some initial time t equal to t naught, and you also know the input for all times t greater than or equal to t naught, then the complete behavior of the system is known to you. Are you getting me? So those variables are known as the state variables. जिन variables के अगर आपको initial conditions पता है और आपको input पता है, तो आपको complete system आपके लिए known हो जाता है. उन variables को state variables कहते हैं. Are you getting me? And these state variables, when you put them in this vector, this is known as the state vector. तो बहुत सारी नई terms आ रही हैं. Let me give you properly these terms. Are you getting me? अभी तक clear पूरा? So some new terms. First is state of a dynamical system. The state of a dynamical system is defined by a set of variables okay, which are actually the dynamical variables, है ना? Such that the knowledge of these variables at some initial time t equal to t naught. The state of a dynamic system is defined by a set of variables, which are actually dynamic variables, such that the knowledge of these variables at some initial time t equal to t naught and the knowledge of input for t greater than or equal to t naught, isn't it? Such that the knowledge of these variables is sufficient to describe the complete behavior of the system for all times t greater than or equal to t. State of a dynamic system is defined by a set of variables such that the knowledge of these variables at some initial time t equal to t naught and the knowledge of input for t greater than or equal to t naught is sufficient to describe the complete behavior of the system for all times t greater than or equal to. Means अगर आपको इन variables की knowledge है for some initial time and you also know the input, then you can solve the system mathematically and physically also you will be able to describe the behavior of the plant completely. Are you getting me? That's what is known as the state of it. तो जैसे हमने अभी आपको कहा, जैसे ही आपको state आया ना mind में, immediately just at the back of your mind it should get to you that it's basically the dynamic variables associated to the system. So state will be defined only for dynamic systems. That means systems which have got energy storage elements. Static systems में state का कोई concept ही नहीं है. Are you getting me? This is defined only for dynamical systems. Are you getting me? So you define what are state variables? State variables are those variables which define the state of a system. है ना? State variables are the dynamic variables which define the state of a system. Are you getting me? Yeah, which define the dynamics of a system. Yeah, which define the behavior of the system. They are known as the state variables. Are you getting me? So you represent state variables like this: x1, x2, so on up to xn. है ना? Are the state variables of an nth order dynamical system. है ना? अगर आपके पास nth order system है जिसमें कि n independent energy storage elements हैं, तो उन n independent energy storage elements के साथ आप n state variables associate कर सकते हो जिनको नाम दिया जाता है x1, x2 up to xn. So these are known as the state variables of a system. Are you getting me? So that is state variable. Third is state vector. If you put these state variables in a column vector, that is known as the state vector. A vector, या ऐसे लिखेंगे हम, a column vector whose elements are the state variables, है ना, is known as a state vector. Getting me? So written like this. So you've got x1, x2, so on up to xn. है ना? This is the state vector. What is the dimension of this vector? n cross 1. Column vector है ना, उसको रिप्रेजेंट किया जाता है x से. Okay? This is the state vector. Short form में ऐसे लिखा जाता है. This is basically a vector. कुछ बुक्स में आप देखोगे, you will find a bar here above, just to designate that this is a vector. है ना? To distinguish between variables and vectors. बुक्स में नॉर्मली क्या करते हैं, वो जो सिंगल एलिमेंट होता है उसको नॉर्मल इसमें फॉन्ट में रखते हैं और उसको बोल्ड केस में रखते हैं. नॉर्मल नाइस में भी, और इवन अगर आप मदन गोपाल देखोगे उसमें डिफरेंट तरीका है. बट द थिंग्स शुड बी, यू शुड, जब भी कोई नया कोर्स पढ़े तो पहले टर्मिनोलॉजी फिक्स करनी चाहिए कि हम पूरे कोर्स में यही टर्मिनोलॉजी यूज करेंगे. तो एक्स बेसिकली स्टेट वेक्टर है जिसके एन कंपोनेंट्स हैं. एज सिंपल एज दिस. आर यू गेटिंग मी? सो दिस इज योर स्टेट वेक्टर. फोर्थ इज स्टेट स्पेस. अब आ गया स्टेट स्पेस. ओके, state space is an nth dimensional space whose